In today's video we're looking at the resistivity and doing current voltage graphs of ohmic devices. So ohmic devices are things like resistors. I'm using a ceramic resistor, a 5-watt resistor, because we will be putting quite a lot of current through it to be able to use our normal equipment. A 12-volt power supply, ammeter, voltmeter, and a rheostat. The circuit diagram for this is on the exam board, so it's a required practical. I'm going to connect positive to the power supply. I'm going to go into the bottom of the rheostat. The rheostat is a variable resistor. It has a coil of resistance wire. If you connect to the other end at the bottom, you're always using all of that resistance wire. If you connect to the top terminal, the amount of wire is controlled by the position of the slider. From the top, I'm going to go into the ammeter, out of the ammeter into the component, our resistor, and the other side of the resistor goes back to the power supply. Last of all, I'm going to add a voltmeter in, and that goes across the resistor. I've used coloured leads to help you see the positive and negative side of the resistor. So I'm going to turn the power on. I've got the slider at this end, so I'm using most of the resistance wire. So I'm getting quite a low voltage, and I can record in a table the current and the voltage. Current in amps, voltage in volts. And I can change resistance. We've got a loose connection there. Change the resistance, take another reading. Change the resistance, take another reading. Change the resistance again, and take half a dozen or so readings, half a dozen to 10 readings. We then need to see what happens when we reverse the current. And we can do that by swapping the terminals over on the power supply. So we're getting negative readings, and they should be very similar for resistor. And we should get a straight line through the zero for a current voltage graph. Now, non-ohmic devices, the first one we'll look at is a light bulb. I'm using a 12-volt, 24-watt lamp. Instead of the resistor, so it's just a case of swapping that over and doing the same experiment again. So as we increase the current, the voltage increases, and we get to the point where it lights up and we get very little current increase for more voltage increase. Swap the terminals over and we can do the positive side of that graph, and we'll get very similar readings. A greater change of current for small voltage changes down at that end. So in this case we are getting if we plotted it on here, we get very little current change for extreme voltages, then fairly straight through the origin, and then we get to the point where it's heating and non-ohmic anymore, and it tails off again. I forgot to bring my pen over here to draw them on here. I drew the graph out and then put the pen away. We'll do the diode in a separate video.